Okay, let's start the lesson by looking at the homework. I'll have Mr. Mathis take questions on any of these that you had. I'm going to put the questions up here where you can see them and have you talk about number 1, 2, 3, and 4. Pause the video and I'm going to scroll down to the rest of them. So here's problem 6. If you want to talk about that one, you can pause the video. The ones that I thought were most interesting here were numbers 9R, which we did, which is here. You can pause the video and take a look at that if you'd like. Number 11 was one I asked you to do, and 13B. So I'll leave these there and go ahead and work with those. And now I'll close the book. And let's look at the question banks. Those I really want you to look at. Whoops. Question banks are these ones. Number 1 right here. Number 13. Number 13 is here, the obtuse angle with a bunch of double angle formula things, and number 14. And I'll scroll down now to the mark schemes for those. So there's the mark scheme for number 1. Pause it if you like. And mark scheme for number 13 is here. Whoops. You can't see quite the whole thing. Let me see if I can bring it up. So, whoops, that didn't work. There, can you see yeah, you should be able to see the whole mark scheme for 13. And there's 14, plus the rest of 15. Rest of 13, sorry. Alrighty, that's the homework, and now we'll move on with the lesson. Actually, what I'd like you to do first, before the lesson, is a little quick quiz. So pull out a piece of paper and get ready, and start the video when you're ready for this little quick quiz. Take 5-10 minutes the most to do these, please. And then give the papers when you're done to Mr. Mathis. Thank you so much. And now let's go on with the lesson. I hope you're getting good with the pause button, Jeff. The lesson today is about the compound angle formula. And what we want you to understand is how to work with trig functions when you have a sum or a difference of angles, two different angles. So you'll remember that one of the common mistakes in trig is to say that something like, the sine of alpha plus beta is equal to the sine of alpha plus the sine of beta. That's not true. That's not true. Sine is a function. It's not a multiplier distributing across parentheses. It's a function. We're putting alpha plus beta into this function, and what the function does to it is very dependent on the function itself. And so we need to understand sine well enough to understand what does it do when you put a sum into it. So we're going to begin by deriving a formula for the cosine of the difference of two angles. And to do that, we are going to use this diagram here and explore it in some detail. The diagram that we have here, you'll see, is the unit circle, and the angle B is the angle to Q here, and the angle A is the angle to P. And so because of that, the coordinates of Q are the cosine of B and the sine of B, and the coordinates of P are the cosine of A, the cosine being the horizontal component, and the sine of A. So this angle that's drawn in black here, that is the angle A minus B, and we're going to look for a formula for the cosine of A minus B. And we start with looking at an expression for the length, PQ, which is the length of this dotted line. And we can get that by the distance formula. That's one way to get it quite easily. And we remember the distance formula comes from the fact that there's a a right triangle associated with any 2 points, and the lengths of the legs of the triangles are the difference in the x components. Cosine B minus cosine A gives me the length of the red. Sine B minus sine A gives me the length of the blue. So in this construction, I've used Q to be the first point, and I'm subtracting the coordinates of P. And you'll notice, for example, that sine of B, which is this height, minus sine of A, which is this height, is going to be negative. But that's okay because we're going to square it when we get to the distance formula. And we get that PQ is this form here. PQ is cosine A minus cosine B, that's the red line, squared, plus sine A minus sine B, that's the blue one, squared, gives me PQ squared. I'm actually not going to take the square root because it's fine to just understand what PQ squared is. So that's an expression for PQ squared, and we can simplify it a little bit more, or expand it, I guess. Take a look at this. We expand this, we get cosine A squared minus 2, twice the product of these, 2 cosine A cosine B plus cosine B squared. And do the same thing with sine. We get sine squared A minus 2 times the sine A sine B, that's twice the product there, and sine squared of B. And if you take a look at these things, you'll see some stuff here. You see the sine squared B and the cosine squared B? Well, what's cosine squared B plus sine squared B? Oh, that's 1. So is sine squared A plus cosine squared A. That's also 1. So what we really get is 1 plus 1. That's the two, all those cosine squareds and sine squareds. And what's left is minus 2 cosine A cosine B and minus 2 sine A sine B. And 1 plus 1, of course, we can simplify that to 2, and we get this little expression here. So that's the beginning, and we know that that's an expression for PQ squared, the length of PQ squared. Now I'm going to do the same thing, but I'm going to look at this from another angle, and the angle I'm going to look at it from now is using the cosine rule in this triangle OPQ. This triangle starting at the origin and with vertices at P and Q. And so I have this angle A, and I have the unknown side, which is PQ squared. So from the cosine law, we get that PQ squared, let's scroll up a little bit, PQ squared, that's this side, is the other side squared plus the other side squared, right? A squared plus B squared, minus 2AB. Well, A and B are both 1, so we just don't even put them there, times the cosine of the angle across from the unknown side. So PQ is this side, that's our like C squared, if you will. And the angle across from that is this angle, this black angle, A minus B. So the cosine is of the angle A minus B. Okay, so now we've got this great situation, which we often do in math. We have two expressions for the same thing, PQ squared. Well, that means they have to be equal, and so we set them equal and do a little manipulation. What do you think we can do here? Well, let's see. I see some 2's. I could subtract that. I could divide by 2. Wow, that's not very bad. I subtract 2 from both sides. That'll nix these things. And if let's divide by negative 2. What the heck? Divide by negative 2. That goes away. That goes away. That goes away. And we get this really great formula, which is that the cosine of A minus B is given by cosine A cosine B plus sine A sine B. And that's a really important result that you'll use quite a lot. Okay. One thing to point out before we go on is that cosine of A minus B results in a plus over here. Cosine, cosine, sine, sine is the way I used to remember it. But the sine of this, the A minus B, is the opposite of what's over here, plus here. So let's go now and develop a few more formulas. The first one I want you to try is to try to find a formula for cosine of A plus B. And I'll give you a hint here. Substitute minus B in for B to get that formula. So pause the video now and you do that and see what you come up with. Welcome back. Now hopefully what you saw is that, well, it's all written under here, so I'm going to just show you. When you put cosine of A minus negative B, you get cosine A cosine negative B plus sine A sine minus B. And of course, a minus a minus b is a plus b, and cosine of minus b is the same as cosine of b. The sine of minus b is the opposite of sine of b, so this plus sign from that minus becomes a minus, and this is sine a sine b. I don't really need the parentheses here, that's kind of overkill. And this stays cosine a cosine b. And so once again, when you have an a plus b, cosine of a plus b, you get cosine a cosine b minus, again, the opposite sign from over here, sine a sine b. That's good for cosine. Let's see if we can do it for sine. What would you do if you want to take these and create a formula for sine a plus b? Well, remember that cosine of an angle is 90 minus the sine of an angle. How could we use that somehow? Cosine, how could we make that? How about, pause the video and see if you can think about it. And here we go. Let's suppose I have 90 minus, a plus b, for example. So we take the cosine of 90 minus a plus b, and that's going to be the sine of a plus b, right? So by using our cosine rule of 90 of a minus b, we're using this cosine rule right here, 90 minus a plus b, we get the sine of a plus b. And so when we plug that in over here, let's see, I'm rewriting this a little bit. It's the same if I call this 90 minus a minus b, as if I, in other words, regroup these parentheses and change this to a minus. That way I can look at this as cosine a, cosine blah, cosine b plus sine blah, sine b. This is the cosine of the difference of two angles, right? So this is my first angle, which I called a up in the formula right here. That's an a. And here's b. So I get cosine of the first angle times the cosine of the second, cosine cosine, plus, which is the opposite of this sine, the opposite of the negative, plus sine blah sine b. And now I'm going to use what I know again, that cosine of 90 minus a is the sine of a. So I can replace this cosine here with the sine, since I've got 90 minus. So I got sine a cosine b, and over here, same thing with this sine, changes to a cosine, and I get that the sine of a plus b is equal to sine a cosine b plus cosine a sine b, or sine cosine cosine sine is the way I remembered it. And now on this one with the sine, this SIG and this positive is the same as this positive. So the two forms to remember are cosine cosine sine sine for cosines with an opposite sign, and sine cosine cosine sine for sine. I know it's a lot of sines and cosines, but you'll get what I mean if you practice a little bit. We can do a very similar thing to get the sine that we did up here with substituting in minus b to get a formula for sine of a minus b. And you can take some time and do that if you like. I'm not going to go through the explanation. It's pretty straightforward. If you just take a look at this, you can ponder it if you like. Same basic ideas. And so that gives us formulas for sine of a plus b and sine of a minus b. And the last one I want to work with today is the formula for tangent. So I want to ask you to use the formulas for sine and cosine, and remember that tangent is just sine over cosine. You can take these formulas, make a ratio, and see if you can simplify it a little bit, and you should develop a couple of formulas for tangent of a plus or minus b. Go ahead and do that, and then we'll give you the big summary. Here they are, the compound angle formulas that we need to know. And again, cosine of a plus or minus b is cosine a cosine b minus or plus sine a sine b. Sine of a plus or minus b is sine a cosine b plus or minus cosine a sine b. Sine cosine cosine sine. Tangent of a plus or minus b, this one's a little tough to remember, but it's tangent of a plus or minus tangent of b, and then in the denominator it's 1 minus or plus, that sign is reversed in the denominator, tangent A, tangent B. These are generally going to be sitting in front of you on a formula sheet, but it's important to see them and work with them, and that's really what we're going to be doing with the homework. So let's try a few examples now and see where we go. There's a couple before you move on. Start with this straightforward one. Simplify cosine of 3 theta times cosine of theta minus sine 3 theta sine theta. What we see, if you look at this, is cosine A cosine B minus sine A sine B. Well, from the formulas we know that that is, and you kind of have to go and look at it, cosine, cosine, sine, sine is a cosine thing. And so this is the cosine of A plus B gives me that form, cosine, cosine, sine, sine. We're going to be looking for that form a lot, so get used to it. And what that is, so this is equal right here. We see that 3 theta is playing the role of theta, of A, and theta is playing the role of B. So this actually is equal to the cosine of 3 theta plus theta, or the cosine of 4 theta. So that's the kind of thing we're looking for. So just get a little bit used to that first pattern, and then we'll go on. All right, let's try another one. Now this one's a little more interesting. Without using your calculator, show that sine of 75 degrees is this fancy surd thing. Well, since we're not going to use our calculator, we got to be working with angles we know. And the key to this problem is to notice that 75 is equal to 45 plus 30. Angles we know, pi over 2 or pi over 4 and pi over 6. So we're going to use our sum of angles formula to say that the sum, or the sine of 75 is equal to the sine of 45 plus 30, and that is sine 45 sine 30 plus, it's the same sign as the plus there, plus cosine 45 cosine 30. And we're not using a calculator here because we don't need one. So we're going to go on and say, what is that? Well, sine of 45, we know that's root 2 over 2. Sine of 30, think about it, that's 1/2. Cosine of 45 is also root 2 over 2. And the cosine of 30 is root 3 over 2. So now all we really need to do is a little algebra to simplify it and see if we can come up with this here. Well, that's actually not very bad, because it's the square root of 2 on top there, plus that's a square root of 6, root 6, and the common denominator of both of these is 4, and sure enough we get what we were looking for right here. So that's the kind of thing you can do with this double angle formula. The compound angle formula. All right, let's try one that's got a little more juice to it. In this case, we've given this equation, and what we're trying to do is find K and B, this K and this B. And wow, that looks kind of nasty. Let's see, where would we start with this? It looks like what we want to do, there's not much that we can do with this side, but over here we have a cosine of x plus b. And as you remember, cosine of x plus b can be expanded so that into different parts. And so let's see if we start with that, what happens. So let's say we'll keep the sine x minus root 3 cosine x. Let's leave that alone for now, and say that this is equal to k times, and cosine x plus b is cosine x cosine b minus sine x sine b. And I'm going to double check that formula every time you use it. Make sure you're using the right one and you got your signs right and all that. And I think I'm happy with that. Let's see, what do we do now? We're trying to get let's try to get all the cosine x's together and the sine x's together. So let's distribute this k and call this k cosine x cosine b, that's a b, sorry, minus k sine x sine b. And now we can take this and let's notice that k cosine b is the amount of cosine x that we have. So here's cosine x and here's cosine x, and we have k cosine b. That's how much we have on this side, and here's how much we have on this side, right? So what has to be true then is that k cosine b, this has to be minus root 3. And over here we also have that minus k sine b times sine x. We have to have the same amount of sine x and the same amount of cosine x on each side. So we know that k sine of b has to be equal to 1, because that's how much sine x we have on this side. So this has to be equal, actually it needs to be minus 1 because we have a negative here. So this needs to be minus 1. So how can we work with that? Well, let's write that equation. K cosine b equals minus root 3. Well, let's solve that for k. That means k is equal to minus root 3 over cosine b. That's coming from this equation right here. That gives us that. And this equation here says that k sine b, I'm misleading here. This needs to be a plus 1 because we're going to subtract. So this k sine b has to be equal to minus 1, right? And that means that we can take this k and put it in here. That's one way to do it. Let's take this k and put it in there so that we get minus root 3 sine b over cosine b. Oh, that sounds familiar. Is minus 1. And now we divide both sides by negative root 3 and rename this tangent, and we get tangent of b is equal to minus divided by minus is plus 1 over root 3, and we're going to have two angles that make this true. B is equal to pi over 6, and the other one is 7 pi over 6. Those are both angles between 0 and 2 pi with a tangent of 1 over root 3. You'll remember, go back to the unit circle. These are tangents of the 30-degree angle. It's this angle here, and that angle is pi over 6, I'm sorry, that's pi over 6, and this is 7 pi over 6. Those are the two angles that will work for B. And now let's see what K is. Well, it says, let's take, doesn't really matter. Let's go back to this. K is minus root 3 over, well, now the cosine of pi over 6 is positive, right? The cosine of pi over 6 is root 3 over 2. And we don't want that because that will give us a negative k, and it says k is greater than 0. So we're not actually going to use pi over 6 because that ends up giving us a negative k. So we're going to cross that out. But 7 pi over 6 gives us a cosine of negative root 3 over 2. Now watch me do this. Minus, I'm going to divide by 2, but dividing by 2 in a denominator is like multiplying by 2 up here. So I'm going to do that. Lo and behold, look what happens. Those cancel, that cancels, and k is 2. I remember doing this problem before. There's a much easier way somewhere where the k equals 2 comes screaming out at you right at the start. You might be able to find that route, but I'm not going to go back and try to work it because, I'm done. I got it. K equals 2 and b equals 7 pi over 6. See if you can come up with that other way of interpreting and figuring out what k is before working the rest of this stuff. See where that takes you. All right, enough for that example. Let's move on. Actually, there's not really much to move on to. We've got just some homework for you. If this is a pre-DP class, these are assignments for us. I want to point out that this section in the book has a huge amount of homework problems, a huge number of homework problems. And especially if you get down number 29 in the 30s, there's some really interesting results, some of which have to do with changing a product of an angle to a sum of angles. Let me see if I can get that for you. Okay, so take a look at a couple of these results here. These are the things that people who are into trig they'll just die over this stuff. There are identities that you can develop in trig, such as this one here. Cosine of a plus b plus cosine of a minus b is 2 cosine a cosine b. I mean, all kinds of little obscure things. Cosine a cosine b, here's a product of cosine times cosine a cosine b, is a sum now of 1/2 of cosine a plus b plus 1/2 of cosine a minus b. And they're using this result to show a bunch of other interesting things, writing products of cosines as sums of cosines, where the sum here, the sum of the cosines, involves the sum of the angles. So somehow we're going to get some 8 alpha and 6 alpha in here. This is going to be 8 alpha and this is going to be 6 alpha to get this. And so we'll have 1/2 cosine 8 alpha plus 1/2 cosine 6 alpha. And that can lead to some very interesting results. Here number 31 and 32 are the kind of summary of, this is the summary of those ideas that were developed in number 29 and 30. And here's some interesting factor formulas. If you have a sum of two angles and you want to write them as a product, you can do it this way. The average, this is interesting, the sine of S plus the sine of D is twice the sine of the average times the cosine of the, what do you call that? It's not an average, it's S minus D over 2. It's half of the difference, basically. But these are all these kind of obscure formulas. They're not in the formula book. You tend not to use them, except if you get really into trig and you find lots of stuff like that. So something to know. Just know that they exist. I didn't ask you to do any of them. So that should do it. Have a wonderful day, and I will see you next time around.